Hi, good morning, just about. Thanks very much for coming through here. It's a pleasure to be here at the AI conference in London. My name is Nick Pentreath, and today I'll be talking about the IBM Developer Model Asset Exchange, some of the lessons learned in building the exchange, and the future of standardized training and deployment for deep learning models. A little bit about me. I'm MLNick on Twitter and GitHub. I'm a principal engineer at IBM, where I work in the Code team. That's the Center for Open Source Data and AI Technologies. I focus on machine learning and AI applications and have a background in the Spark project, Apache Spark. I'm a committer in PMC on that project and wrote a book, Machine Learning with Spark, which is a little bit out of date now. So a little bit about the Center for Open Source Data and AI Technologies, or Code. When I joined this team a little over 2 years ago at IBM, it was called the Spark Technology Center, and the focus was, to advance Apache Spark out in the open source community, and in particular, in the enterprise and IBM's customers. So it's an open source team focused on Spark and the surrounding ecosystem. And since then, the focus of the team has really broadened quite significantly. And it's not just Spark and the ecosystem and community around that anymore. It now is focused on the enterprise AI lifecycle. So that includes still Apache Spark, obviously as a core part of that, but also the Python data science stack, deep learning frameworks, standards for model deployment, and a couple of open source projects that we've launched this year that I'll be talking about today. So the first is the Model Asset Exchange, and the second is the Fabric for Deep Learning. So why do we really care about enterprise AI and the end-to-end deep learning sort of life cycle? That's pretty easy, right? You just have data, you train a model, and you profit. Or if you don't have data, or if you don't have the expertise to train a model, you're a domain expert or an app developer, you just find a model, deploy it, and again, you just profit. Simple, right? But in reality, this process is a lot more complex. And there are three larger phases here: discovery, execution, consumption. So in discovery, you have to go and find a model out there somewhere. You have to get the code or get the model. You have to test and verify that model and fix any issues that you find. Then in the execution phase of the process, you need to either train the model on your own data, or if you don't have the data, or if you can find a pre-trained model that does what you need, you can just deploy it. But once you've trained the model, you would also need to go and deploy it into your application. And the final phase is consumption. Once it's deployed, you need to use that model in your application to do something in the real world. So if we step through each of these in more detail, step one is find a model. So you have a use case in your domain, an application. So does a model exist out there that does what you need, so it meets your business case, or the particular application that you have, the problem that you need to solve? Is it free to use? So what are the licensing implications around the IP, the model code, the model weights, and all of that? And then finally, is it performant enough? Does it meet the performance requirements of your application? So that could be both computational performance, is it fast enough? What are the resources required to train it, perhaps? But also, is it accurate enough on the particular problem or the domain that you have? So that involves a lot of searching through, trawling through GitHub, research papers. In the case of some models, like an image classifier, you might have many, many results. So what is the process of deciding which model is the best to use, finding the state of the art, kind of vetting which is the most appropriate model? So once you've done that, the next step is to actually go and get that model. So if you want to train the model from scratch on your own data or do transfer learning, is there a good implementation out there? In many cases, your teams may not have the expertise or the resources to go and write an implementation from scratch or adapt something from a research paper. So hopefully, you might go and find code that's out there. And again, you need to go and find code or a pre-trained model that meets these requirements. Does it actually do what you need it to do? Is it a faithful implementation of that model in that research paper? What are the licensing implications around both the code and the pre-trained model weights and the data set that it was trained on if you are using a pre-trained model? And is it performant enough for your application? So once you've found the model that meets all these requirements, the third phase, or the third step, is to verify. So it's not enough to just take it on faith that the model does what it says on the tin. You need to step through the code, verify that the model matches the problem, that the output is what you need. So if it's a classification problem, is the label set appropriate for your application? You need to verify code quality, correctness. You need to go back and verify that licensing. So check provenance of code, and has it been taken from somewhere else where maybe a new license put on it where maybe that is actually not allowed, or there are legal implications there. And finally, performance. Does this model perform as per the original kind of research implementation on your particular domain? So once you've completed that discovery phase and you're through to verifying everything, you then need to go and train and deploy, or in the case of a pre-trained model, simply deploy the model. So training is all about loading, analyzing, preparing the training data, so all the pre-processing involved in that. Training and analyzing and tuning model parameters, and applying the expertise and the compute resources required to come up with that trained model. So this is the subject of many potential conference talks just on its own. But there's a lot of complexity that is hidden in this part of the process. And once you've solved that problem, you need to figure out how to deploy this model. So you may need to develop further inference code from scratch or customize existing code. For example, many training implementations may be optimized for batch processing. You need to, but not for single instance inference. So you need to go and solve that. You need to then package up the code for inference together with the pre-trained model artifacts and deploy that to some serving environment. So this, again, is potentially the subject of an entire conference talk. There are many different ways of solving this problem. But once you've done all of these steps, you then need to use the model. So this is about consumption. You need to integrate it with your application. Now, the application doesn't know about tensors, right? It doesn't care about TensorFlow or Caffe or PyTorch or Kubernetes or whatever mechanism you're using to train and deploy. It doesn't really know anything except what is the raw data that the application is dealing with and what is the outcome that it wants, right? So in terms of integrating into the application, we need to abstract that middle piece, that sort of inference, away. And we need to wrap it in a nice interface. So that business users, application developers can simply deal with that interface or that API, send it data or send it an input, and get back a result that it can actually use. So not a tensor of predicted classes or probabilities, but a set of string labels in a nice format, for example, JSON, that it can actually consume. So those are all the steps involved, and for each of these phases, discovery, execution, consumption, there are many challenges, and I'll walk through a couple of the main ones. So in terms of discovery, well, how do you go and first of all find a model that is the right thing, get the code, test it, and verify it? Well, that's simple, right? We just go to a model zoo. That's an easy place to start, right? Everything is nicely cataloged. It's easy to obtain. It's referenced, right? Wrong. Okay. This is what most model zoos look like, and most kind of repositories out there. Okay, it's a bit of the Wild West. Nothing is referenced, nothing is indexed. It's very difficult to find metadata about what is the input and output of the model. What is the training data used? What is the licensing? Modularity in terms of code quality. A lot of these models are coming from research teams very admirably, right? It's all being released for free. That's great. But it's really optimized and focused on training a model for research purposes and not for production purposes or implementing it into application. So this is the main challenge is curation, homogenizing the metadata and the presentation of models, and having one place where you can go and find them. So when it comes to training, much like going and training in the gym, there are many, many different ways of doing it. And in fact, there's an entire zoo of model frameworks and deep learning frameworks out there. And each one has their own way of dealing with input data, their own way of training and tuning, cross-validation, their own way of dealing with distributed training, GPU support and other accelerator support, model formats, serialization, the list goes on. So when it comes to deployment, again, there are many, many, many ways of deploying the models. And there are frameworks out there. In particular, containers have become a very popular way of deploying software in general, but certainly on the machine learning side and the deep learning side. So deploying with containers is one way of trying to solve this problem, and it does help a lot, right? It has a lot of benefits, so ease of configuration, repeatability. It really focuses on the, or allows the data scientists to use the tools that they are familiar with and focus on the what of that model, rather than the how of how it's deployed. So they can focus on code and not worry about DevOps and infrastructure. So containerization takes care of that, but really what goes into that container is the important thing. So thinking about that consumability and consumption step again, the application still doesn't care about tensors. So what goes into that container needs to still be wrapped up in some sort of serving framework that is required on top. Containers by themselves don't just take care of standardization of the formats and the APIs exposed. So that final step of consumability, and it is not actually just the final phase. It sort of runs through all of the phases. And one of the goals that we as an open source team at IBM and within Code A and our larger group have is to make AI ubiquitous in the enterprise and to make it as easy to consume in enterprise applications as possible. And a good example of this is the telephone, right? So everyone within IBM has a phone. And everyone knows how to use a phone, and it's a central tool for doing business. But that doesn't mean that IBM is a phone company, right? So how do we go about making AI as ubiquitous and easy to use as a telephone in an organization? And a big piece of this is standardization and the interface, right? So all of these phones are the same, right? They're not exactly the same, but where it matters, they're the same. They all have the same interface for dialing a phone number. And if you know how to use one phone, you know how to use the other. So standardization is key to making this, this consumability story smooth and this ubiquity story in enterprise possible. And this is what we've tried to do and set out to do with the Model Asset Exchange. So Model Asset Exchange is a free resource for open deep learning models. It's a centralized repository that covers a wide variety of domains, text, images, audio, time series, healthcare, and more, and growing. Importantly, the code and the IP for all the models on the exchange is carefully tested, vetted, so you can, as a user of the exchange and the models on the exchange, be comfortable that you don't have to worry about these legal issues. We have two types of models, trainable and deployable. And a deployable model can be deployed as a model web service and REST API in less than 30 seconds in one line of code on Docker and Kubernetes. And for training, we allow you to get started in a few minutes on training with either the Fabric for Deep Learning or Fiddle or IBM's Watson machine learning service. So starting off with trainable models, I've mentioned Fiddle, and what is that? And why do we want to use it, right? How does it solve this consumability and standardization problem? Fabric for Deep Learning is a recently released open source project that's curated and managed by the Code A team. And it comes out of IBM research, and it actually forms the core for IBM's Deep Learning as a Service commercial product offering in the cloud. Fiddle is a Kubernetes-based sort of meta framework for training deep learning models. So you can use any of the standard frameworks, TensorFlow, Caffe2, PyTorch, now merged, Keras. And it provides a standardized approach to dealing with training data, the framework code, and a training configuration. So all you need to do is package those three pieces up and train them on Fiddle. So as a data scientist or machine learning engineer or practitioner training models, you don't have to worry about how do I set up and deal with clusters of different kinds of deep learning frameworks. How do I make sure that my GPU configuration and access is correct? How do I manage scalability across nodes? That's all taken care of by Fiddle. And for managers of clusters and the DevOps teams and the ML ops teams, this makes it easy for them to use an existing Kubernetes cluster, deploy with a set of scripts, and ensure that they can run all these deep learning frameworks and support all of them with full hardware support, GPU, file systems, object storage. So some recent news for Fiddle. It now fully supports PyTorch 1.0. So that's effectively the merger of Caffe2 and PyTorch, which as part of that also supports exporting models in the Onyx format and serving them on the model serving platform that's part of Fiddle. With the extensions, and it also supports distributed training with Horovod for various frameworks. So for a trainable model on Fiddle, the process becomes you go and choose a trainable model, pre-vetted, that does what you need it to do, and you'll be packaging up your training data, which is the data you want to train on, your own data. The training code, which is provided on the exchange, and the training definition file, run that through a standardized script and train it on Fiddle. And because Fiddle is the core of IBM's cloud platform for deep learning as a service, training on Fiddle and training on a managed service on the cloud is a simple, small configuration change. So you can either do that on your own Kubernetes cluster if you want to go and manage Fiddle yourself, but if you don't want to do that, there's a managed service for that. So on the deployable side, on the consumption side, so you may want to train a model from the exchange, but a lot of the time you might just want to simply deploy a pre-trained model. And this is true for the case of you could still be a data scientist who finds a model that actually does what you need to do, so you don't have to train it. But in many cases, this is for domain experts and application developers who may not be experts on deep learning or machine learning, or may know nothing whatsoever about that. But what they do know is their domain, their application, and they can use a REST API and a web service. So a deployable model on Model Asset Exchange is not just the pre-trained model, but we solve this use case and consumption story by dealing with the input and output processing that's required and putting it all behind a REST API. So there's standardized model wrapping code that exposes one predict method, and under that predict method, as part of that, it's going to be doing the standardized API for input processing, output processing. So image resizing, cropping, or tokenization for text, or whatever the case may be. And then on the REST API side, that's a standardized REST API Flask application with a Swagger definition. So in deploying that service, which is wrapped up as a Docker container, you end up with this microservice which deals with the full end-to-end pipeline from raw data through pre-processing, model execution and inference, and output post-processing. And you also get a standardized Swagger specification, which allows you to use the automated tooling around the API definition, explore the user interface, an inference endpoint, metadata endpoint, to get, for example, the labels of a classification model. And this is still in development, and we're going to be adding more features to this. Okay, so I think the best way of kind of illustrating how this all works from the deployment side is to do a demo. So let us hope. Let us hope that the demo will work today. Okay, so this is the current front page of the Model Asset Exchange. We actually work on a new updated version of the website, which I'll talk a bit about later. But you can see we have all of these models, and behind each one of these is really a GitHub repository which contains all the code. So as part of that GitHub repo, we've got a model description telling you what this model actually does, some metadata telling you kind of where it comes from, some of the references behind it, what is the training data, what is the formats for inputs, what is the licensing applicable. So you can verify all of these points that are required to make sure that the model does what you need it to do. And then we have one-line deployment on Docker Hub or on Kubernetes using those Docker containers. You can, of course, completely customize this if you want, go and run it locally, and use it as you see fit. So also, as part of this, as part of the Model Asset Exchange, we want to make it easy to actually use these models in an application and to illustrate how to do that. So IBM Developer has a range of different content that we put out, ranging from blog posts to how-to guides. And one of these is called a code pattern. And now a code pattern is a kind of extended how-to guide, a blueprint for how to do something useful and in an end-to-end sort of format. So walking through from start to finish how to build an application. So one of these code patterns is actually still in development, so this is going to be a sneak preview. But this is an image segmentation model, right? And it takes in an image, and for each pixel in that image, it returns a label. So you can use that to generate segmentation maps for all of the objects in an image. So that's all great, and we can deploy this. We can deploy this service just with that one line using Docker. And this is the Swagger user interface that is exposed. So as an application developer, web developer, for example, this is a very common interface, and it's very natural. So you can go and have a look at the endpoints. You can understand very simply what is the input required. You can see what the output format and schema is, and you can go and try it out. So you can choose a file, an image file, send it through, and you'll get back a bunch of JSON. So that is useful, but it's kind of tricky to understand what am I actually going to do with that. So what we're going to do is we're going to run the preview version of this code pattern, which is our magic cropping tool. So we're going to, this is a web application that's been developed that will call these API endpoints and do something with them. Okay, so this is the Max Image Segmenter Magic Cropping Tool. It is out there on GitHub, but it's kind of not fully released yet. So this is a sneak preview. So we can upload an image, and it's gone ahead and called the API, and it comes back with the objects, right? So it tells us we've identified a train, and we can just crop that out from that image. We can see that that is the segmentation map that is coming back, and we can add another image. So let's say this image of a man in front of some sheep, and again it's identified some people, sheep. We can kind of crop that out. So if we want to put him in front of the train, we can just move him over there. Or maybe want to add some sheep in front of the train. Well, that would be a bit probably animal cruelty, so put them off to the side. So this is a fun application, and it's showing how to actually use these models. And as you can see, with one line of code, we went ahead and deployed that service. And obviously there was development that went into the web application, but again, one-line deployment via Docker containers. And this is all available for free on IBM Developer and GitHub. And it's really sort of illustrating how you can go from zero to a fully functional, useful web application, in a very short space of time that is using machine learning and deep learning models. So, in summary, the current status of Max is, we launched it earlier in the year. The first version was done, in a rush within 3 weeks to kind of launch at a conference. So, there's a lot of work that's still to be done on it. But we've got currently 22 models, mostly focusing on the consumption and deployment side, so making it easy to deploy them. These various types of models as the Docker containers. 4 of them are trainable on your own data. Using either Fabric for Deep Learning or Watson's machine learning service. We're covering a wide variety of domains, and there are currently 3 published code patterns demonstrating how to consume those Max models in a web application. And they cover object detection, image captioning, and a few kind of useful and interesting use cases. We have another code pattern that demonstrates how to train a transfer learning model, in this case an audio classifier on Watson machine learning. And we recently added this one-line deployment via Docker Kubernetes, so standardized Kubernetes config files so that you can just deploy it to your kube cluster with one line. In the future, we've got a new Max web portal, which will be launching soon. I'll actually just show you, again, a sneak preview of that. So this is an example of a model landing page. So you can come along here, and it's got pretty much the same information in terms of what is the model metadata licensing around that, as well as quick one-liner deployments, example use cases. You can actually try the API out without even doing executing any code. These are publicly hosted endpoints that you can go and try it out. You can obviously get the code on GitHub, and we'll be adding more and more features. So that should hopefully be released in a few weeks' time. A big focus is obviously adding more models. We want more breadth, more depth. We want more deployable models covering more use cases. And this is where it would be great to hear feedback from people out there who are interested in Max. What use cases are you seeing? What kind of models do you need? What domains are important? We're going to be focusing on trainable models, in particular transfer learning. We believe as a team that training very large models from scratch on huge amounts of data, while that's where a lot of the interest is and the buzz, it's not really the biggest value add for most use cases and applications, and in particular in the kind of medium-sized enterprises. In most cases, it's going to be transfer learning on relatively smaller amounts of data using good pre-trained models. So we really want to open up those use cases on Max, make it easy to do transfer learning in domains such as images, text, especially in the beginning, and to be able to run those on Fiddle or on our cloud service. More Max-related content. So we're doing a lot of conference talks, meetups, getting out there, talking about Max, finding out what people think about it, what you might want to see. Workshops, longer workshops to actually focus on both the training and data science side. So how to use Fabric for Deep Learning, how to wrap up a model for training on the service, and then once it's deployed, how to wrap it up as a Max model for deployment, all the way through to developer-focused workshops. So how to take that model API server and how to create a web application using it. We're focusing on enhancing the production readiness of these models. So you've got one-line deployment to Kubernetes, but if you want to use that in production, we continue to work on better error handling, having things more robust, inference performance, all of these kind of things. And the final one is improving the Max API framework. So at the moment, we try to make things generic and modular. but we really want to get to a point where, where this is a standardized framework, where you can take the skeleton or base framework code that we have, check out that base framework on GitHub and use it to develop your own kind of Max model. And over time, we're going to have we aim to have hopefully a pip installable package so that you can just do a pip install of the Max framework, write a little bit of extended wrapper code, and we take care of all the boilerplate for you. So on that note, at the moment the exchange is obviously free and open source, everything that's on there. But our team is carefully working through and curating and adding models. Some of them are now coming from outside our team within IBM. So we're focusing on data science use cases and IBM research. But over time, we definitely want to open this exchange up and allow people to upload their models, right? So there is a bit of process involved in that. Obviously, a big part of this is curation and verification. But we want to make all of these framework tools as easy to use as possible and remove a lot of the boilerplate so that the community can focus on wrapping up models, putting them on the exchange, and we can streamline that process. So if you are interested in that part of it and you have things that you might want to talk about contributing, definitely please reach out to me. So in summary, IBM Developer Model Asset Exchange, or MAX, is a collection of free and open source deep learning models covering a wide variety of domains, multiple deep learning frameworks wrapped up in a standardized, easy to use training API or REST API in a Docker container, build and deploy a web service within seconds, get training on your own data in minutes. So you can go and visit the Model Asset Exchange at the top left link, and the bottom, the middle link is for all the code patterns and content that is related to Model Asset Exchange on IBM Developer. And definitely reach out to me if you want to learn anything more about the projects that we work on at Code A. So that includes Max that I've talked about, the Fabric for Deep Learning. Earlier this year, we released the Adversarial Robustness Toolbox, which is all about handling adversarial attacks and defenses in your training code. That's fully integrated with Fiddle, so you can integrate an adversarially robust model into your training pipeline. And just last week, I think, or 2 weeks ago, we released the AI Fairness 360 Toolkit, which is coming from IBM Research. It's now, it's public on GitHub, github.com/IBM. And AI Fairness 360 is a collection of state-of-the-art tools for detecting and dealing with bias and fairness in data sets. Again, completely integrated with Fiddle so that you can integrate that debiasing and fairness checking into your training pipelines. So reach out to me and connect if you're interested in learning anything more about these projects. Thanks very much.